Hello all. So in today's class, let us look at what are called measurable sets. ഇനി നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സുകളിൽ ഔട്ടർ മെഷർ എന്താണെന്ന് കണ്ടു. ഔട്ടർ മെഷറുമായിട്ട് റിലേറ്റഡ് ആയിട്ടുള്ള കുറെ prepositions കണ്ടു. അപ്പോൾ അതിനകത്ത് നമ്മൾ കണ്ടു ഔട്ടർ മെഷർ ഓഫ് an interval will be length. ഇനി ഔട്ടർ മെഷർ കൗണ്ടബിൾ സബ്അഡിറ്റീവ് ആയിരിക്കും. ഔട്ടർ മെഷർ ഫൈനൈറ്റ് സബ്അഡിറ്റീവ് ആയിരിക്കും. അതുപോലെ ഔട്ടർ മെഷർ എന്ന് പറയുന്ന ട്രാൻസ്ലേഷൻ ഇൻവേരിയന്റും ആയിരിക്കും. പക്ഷെ നമ്മൾ ഒരു മെഷർ ഡിഫൈൻ ചെയ്യുമ്പോൾ മെഷർ മസ്റ്റ് ബി when you take the ideal measure must be countably additive ആയിരിക്കണം. So here when you take the measure n star, that is just countable subadditive. So if you reduce the domain, അപ്പോൾ നമ്മൾ outer measure it is defined for any set of real numbers. നമ്മൾ real numbers in the either subset എടുക്കുമ്പോൾ we can obtain the value of n star. So the domain of n star will be all the subsets of real numbers. Now let us reduce the domain of the outer measure so that we can obtain a measure which is countably additive. So that we will do in the coming classes. Okay. So for forming a measure which is countably additive, so we will define first what are called measurable sets. അപ്പോൾ അത് എങ്ങനെയുള്ള ഡൊമൈനിലാണ് ഡിഫൈൻഡ് ആയിട്ടുള്ളതെന്ന് നമ്മൾ നോക്കും. അപ്പോൾ ആ കേസിലാണ് നമുക്ക് സിഗ്മ ആൾജിബ്ര ഒക്കെ വരിക. ഓക്കെ, സോ ലെറ്റ് us first define what is called a measurable set. Let us look at the definition of a measurable set. So a set E, ഇപ്പോൾ നമ്മൾ ഇപ്പോൾ ഡിഫൈൻ ചെയ്യാൻ പോകുന്ന മെഷറബിൾ സെറ്റിന്റെ ഡെഫിനിഷൻ ആണ്. ദറ്റ് ഇസ് ഡിഫറെന്റ് ഫ്രം ഔട്ടർ മെഷർ. ലെബക്ക് ഔട്ടർ മെഷർ എന്ന് പറയുന്നതാണ് എം സ്റ്റാർ. നൗ വി ആർ ഗോയിങ് ടു ഡിഫൈൻ വാട്ട് ഇസ് ദ മീനിങ് ഓഫ് എ മെഷറബിൾ സെറ്റ്. സോ എ സെറ്റ് E is said to be measurable if for each set A, so A is an arbitrary set, so a set E is said to be measurable if for each set A, so n star of A must be equal to, so we have n star of A equal to n star of A intersection E plus n star of A intersection E complement. So if this holds, so a set E is said to be measurable if for any arbitrary set A, n star of A must be equal to n star of A intersection E plus n star of A intersection E complement. ഇനി നമ്മൾ രണ്ട് സെറ്റ് എയും ഇയും എടുക്കുകയാണ്. സോ A can be expressed as, so A will be equal to, ഇപ്പോൾ ഇതായിരിക്കും A intersection E എന്ന് പറയുന്ന പോർഷൻ, and this will be A intersection E complement. So this is A intersection E, A intersection E complement. So A can be written as a union of these two sets. So A intersection E union A intersection E complement. Now by the property of outer measure, so n star of A is equal to A എന്ന് പറയുന്നത് A intersection E union A intersection E complement. So by subadditivity, so this will be less than or equal to m star of A intersection E plus m star of A intersection E complement. So m star of A will be always less than or equal to m star of A intersection E plus m star of A intersection E complement. So the set E becomes measurable when this is greater than or equal to, less than, രണ്ടും equal to ആവണം. അപ്പോൾ ഓൾറെഡി ലെസ് ദാൻ ഓർ ഈക്വൽ ടു ആണ്, അത് നമുക്കറിയാം. ഇനി ഗ്രേറ്റർ ദാൻ ഓർ ഈക്വൽ ടു ആണെങ്കിൽ ദിസ് എക്സ്പ്രഷൻ വിൽ ഹോൾഡ്. സോ വി കൻ സേ ദാറ്റ് ദ സെറ്റ് E is measurable. So this happens always. So therefore E is measurable if and only if, so when you take n star of A, n star of A must be greater than or equal to n star of A intersection E plus n star of A intersection E complement. അപ്പം നമുക്ക് മെഷറബിലിറ്റിയുടെ കണ്ടീഷൻ നമുക്ക് ഇങ്ങനെ പറയാം, ഒന്നുകിൽ n star of A equal to n star of A intersection E plus n star of A intersection E complement, അല്ലെങ്കിൽ if n star of A is greater than or equal to n star of A intersection E plus n star of A intersection E complement. This is also a definition of measurability because the other way it is always true. This is the definition of measurability for the set E. If measurability definition, it will be symmetric for E and E complement. So if you replace E and terms angotu ingotu maati ezhiyal, we'll get that E complement is also measurable. So by the symmetry of the definition, we have, so E complement is measurable whenever E is measurable. And again, the examples of measurable sets are, so phi, the empty set, and the set of all real numbers are measurable. So let us look at how they are measurable. So for any set A, so let us take the case of phi. So we have, so when you take A intersection phi will be equal to phi, and A intersection phi complement, that will be equal to phi complement എന്ന് പറയുന്ന R ആണ്. So intersection R will be equal to A. So n star of A intersection phi will be equal to n star phi, which is 0, and n star of A intersection phi complement will be equal to n star of, so that will be equal to n star of A. So on adding both, we'll get n star of A equal to, so n star of A intersection phi plus n star of A intersection phi complement, that will be equal to n star of A. So that implies phi is measurable. So the definition of a measurable set holds. So therefore phi is measurable. So same in the case of R. So for any set A, when you take A intersection R will be equal to A. അതുപോലെ A intersection R complement will be equal to phi. So that is equal to phi. So n star of A intersection R plus n star of A intersection R complement will be equal to A intersection R എന്ന് പറയുന്നതാണ്. So n star of A plus n star phi വരും. n star phi is 0. So that will be equal to n star A. So that implies R is also measurable. So the empty set and the set of real numbers is measurable. And let us look at a lemma. So if n star E is equal to 0, then E is measurable. So we need to show that if n star E, so if you have a set E such that its outer measure is 0, then E is measurable. So for any set, so let us prove the result. So consider any set A, then when you take A intersection E, so A intersection E will be contained in E. അതുപോലെ A intersection E complement എടുക്കുമ്പോൾ let me take that to be contained in A. Okay. So if A intersection E is a subset of E, so A intersection E is a subset of E, that implies, So when you take the outer measure, so if A is contained in B, then M star of A will be less than or equal to M star of B. So here M star of A intersection E will be less than or equal to M star of E. But it is given that M star E is 0. So M star A intersection E will be less than or equal to 0. So call this as equation 1. And from the second equation, from the second set we have, so A intersection E complement is contained in A, so that implies M star of A intersection E complement will be less than or equal to M star of E. So call this as equation 2. Now let us add 1 and 2. So upon adding 1 and 2, we will be getting M star of A greater than or equal to M star of A intersection E plus M star of A intersection E complement. Okay. So this was the condition for set to be measurable. So നമ്മൾ greater than വെച്ചിട്ട് ഒരു കണ്ടീഷൻ ആദ്യം കണ്ടിരുന്നു. സോ നമുക്ക് മെഷറബിൾ ആണെങ്കിൽ രണ്ട് കണ്ടീഷൻ ആണുള്ളത്. ഓക്കെ. സോ here we have got M star of A greater than or equal to M star of A intersection E plus M star of A intersection E complement. So by the definition of measurability, so E is measurable. So we have got M star of A greater than or equal to M star of A intersection E plus M star of A intersection E complement. So therefore E will be measurable. Now using this fact, so if E is any set such that the outer measure is 0, then E is measurable. Now we know that when you take the set of natural numbers, set of rationals and set of integers, അതിന്റെ എല്ലാം outer measure 0 ആണ്. നമ്മൾ already prove ചെയ്താണ്. Okay. So these are all sets such that the outer measure is equal to 0. So therefore these sets N, Q, Z are measurable. So these are measurable sets. So that so this holds by the lemma we have seen. So therefore in general we can conclude that, so in general any countable set and any finite set is measurable. So countable set and finite set നമ്മൾ already കണ്ടു outer measure 0 ആണ്. So in general any countable set and any finite set will be measurable.